Hello, Math 30-2, and welcome to lesson 1.2. This one's going to be more focused toward Venn diagrams. So I kind of talked about it last lesson, like what a Venn diagram was. So it's going to look something like this. It's going to have a square or a rectangle around the outside that's going to just contain all of the elements inside of it. So our universal set. And then you're usually going to have two or maybe even three different circles inside that may or may not overlap. So here's a typical kind of question that we're going to start to see, though. So it says a class of 28 students was surveyed and asked if they ever had dogs or cats for pets at home. This is what they found. 8 students said that they only ever had a dog. 6 students said that they only ever had a cat, and 10 students said that they had a dog and a cat. So it's going to become important words like and, that they had a dog and a cat. That'd be different if it said a dog or a cat, which we're going to see later. But these kind of keywords are going to be important. So the way we're going to start here is we're going to make this circle, this one here, that's going to be our dog circle, we're going to say. The next one, that's going to be our cat circle. So then it says 8 students said that they only ever had a dog. So what we do is we write 8 over in this side of the circle, not over here, right? We want it in the part of the circle that doesn't intersect. So 8 people only ever had a dog. And then we'd say 6 students said they only ever had a cat. So 6 would go over here, right? Not in the middle area though. And then finally it says 10 students said that they had a dog and a cat. So there would be 10 students in this place. So now it says how many students have had at least a dog in their house. So now if you look at everything that's in this dog circle, well, that's going to be this 8 and this 10. So it looks like at least 18, 10 plus 8, have had a dog in their house. Only these 6 have not even had a dog at all, right? So now it says how many students have had at least a cat in their house. Well, that's going to be these guys over here that have nothing but cats, and then these 10 that have a dog and a cat. So there's going to be 16 of them. How many students have never had a dog or cat? So students that have never had a dog or cat, well, what do these numbers here add up to? So we've got 8 plus 10 is 18, plus 6, so that's going to be 24, right? So 24 have had a dog or a cat, right? One of the two. So we want to know what's left. So if you think about it here, it said that the universal set, maybe we should have done this to begin with, we would have wrote 28 up in the top, saying that there are 28 in total, right? That's the universal set. That's going to be everything. So actually, you wouldn't write that 28, though. What we would do is we'd write what's left. There'd only be 4 left there, right? Because it adds up to 24. And then there'd be 4 that'd be like outside of that Venn diagram. And technically, if you wanted, you could have that 4 really just anywhere outside of those circles. That could just be saying, like, there's 4 left outside there. So if you want to down here, we could say, well, there is 28 total, right? People that were surveyed, right? And if you added these 3 numbers together, you get 24. So 28 minus 24, there's 4 people that don't have a dog or a cat. Okay, so now we're going to move on to a little bit tougher ones where they're just tougher because we're given less information is what's going to happen here. So we have to kind of figure out kind of the missing info here just through logic. So this example, next one, says in a group of 30 students, 21 students are taking math this semester, 16 are taking English, and 6 aren't enrolled in either. How many students are enrolled in both math and English this semester? Use a Venn diagram. So let's kind of go through these and kind of figure out some things though. So number 1 says, how many students are enrolled in math and or English this semester? So both, right? Or like one or the other. They might just take math, they might just take English, or they might take math and English, right? So and or. So we can't really just look at 21 students and 16 students taking English because we don't know like what mix might be taking both, right? Some might be taking only math, some might be taking only English, and some might be mixing, and we don't know what that mixture is. But we can figure something out here, right? Because it says in a group of 30 students, 6 of them aren't going to be enrolled. So all we have to do is go 30 minus 6. So there's going to be 24 students taking math and or English. Okay, so now that we know that there are 24 students taking math and or English, what we're going to do, these Venn diagrams help to think about this now. This is why we do this, because really what we're saying when we say and or, so 24, we're saying that that accounts for both of these circles, right? All of that would add up to 24 from like, the whole thing would be 24, right? So now if we say, well, 24 are enrolled in math and or English, so like both circles combined, everything inside them, and 21 are taking math. So now let's figure out what taking math would be. So let's say this will be our math circle and this will be our English circle. So if 21 are taking math, that's this, right? That would be this whole thing here. 21 are taking math. So if I go 24 and I subtract this 21 that accounts for this entire circle here, what I would be left with would be this. People taking just English, right? So for that one, if I just go 24, the whole thing, right? And or like math and or English, and I subtract everything in math, so subtract 21, we get 3. So now I've figured out part of my puzzle, right? This is kind of a puzzle that we're working through. I've figured out that this part is going to be 3, right? What I'm after is I'd like to figure out what just this part is and what just this part is. That's kind of what the end goal will be. We figured out part 1 of our puzzle. Okay, so now it says if 16 students are taking English and only 3, what the number we just found, are taking just English, how many students are taking both math and English? Now be clear about your words here, both math and English. We're talking about the overlapping area here. So now all you have to do is just realize that when it says, so 16 students are taking English, so that, remember, would be this entire circle, right? So 16 would account for that whole thing. So if I go 16 minus only the 3 in there, I should get what's left here. So 16 minus 3 is going to be 13. So there should be 13 students that are taking both. So we figured out that part of our problem now. So now you can see that if I just go 24 now, the whole thing, and I subtract 16, I should be what's left with just math. So actually, though, there's 2 ways to do this, because you could go 24 minus 16 and you'd be left with what's over here, right? But the way that the question's kind of pointing us, it says, so there's 21 students are taking math, so that's talking about this circle, right? That one there. So, so 21 taking just math, we figured, or taking math in total there. 13 are taking both math and English. So if I just go 21 minus 13, then we end up with, so here, I'll write this down. 21 minus 13 would be 8. So I know that there's 8 taking just math. So that's kind of the roadmap of how to get through these things. It's a puzzle. You're just trying to solve each part of the puzzle as you go through. This is a pretty typical kind of question that you're going to get in this unit. So the other thing, though, the other way that we could have done this in a simpler step here, well, maybe not simpler, it depends on what you think. I kind of like the Venn diagrams. I find them pretty kind of just like a puzzle, like I was saying, is what we could have done is if you think about these circles, this kind of thing, before we kind of look at like what this is algebraically, let's think about if you had 2 Venn diagrams, or sorry, 2 circles making a Venn diagram, and I wanted to figure out what the whole area of this thing was, so like this whole surface from there to there, then the equation to make that would be the area of the purple one. No. Oh, no. Okay, good. I thought I stopped it. Okay, I thought I stopped the video. We're good. All right, so sorry, the area of the purple one plus the area of the blue one, right? But you can kind of see what I did there is I ended up counting that middle section twice, right? The place where they overlapped. Because if I add up the purple one and I add up the blue one, I've added too much. So what I have to do to make this right is I have to subtract the area of the center one. And that's where this equation here comes from. So we can do this algebraically. If we say m, so the area, you can think of the area of m, and this as E, and then B is our center. So you can think about that as we have to think about it. So if you go M plus E, and then to account for the fact that we counted that middle section twice, we have to subtract the middle section. So what we can do is we can write this out algebraically as 21 plus 16, that's E, right? Minus B, that's what we don't know. And that's what we had to figure out in that one, right? That was our missing piece of the info, or one of them anyway. And that's equal to 24, right? That was the people who took both. That makes up this whole circle there. So we could start off by that and then just solve for B. So if I subtracted B from both sides, I could just rewrite this as, so bring B over here, and we'd have 21 plus 16 minus 24, and we get 13. Right, so that is our center. That's what we found using our other method that we use up there. But you could find that algebraically, and then once you know that, then we can figure out that one and that one pretty easily just by subtracting 13 from whatever m was. Okay, hopefully that made sense. I know it's kind of like it's a logic puzzle, right? Like you can just get lost in this stuff pretty quickly if you don't pay attention. Okay, so let's do another one here. So it says a marketing company surveys 100 students. So 100 students would be the what the universal set would be made of, right? There'd be 100 in total. Like inside this box would be 100 students. Okay, they found that 75 students owned a cell phone. So first off, let's just write, well, just because car and cell both start with C, I'm just going to actually write cell and car. So that's going to be those ones. Now, the key bit of information here, what we kind of want to do, like our logic puzzle here, is I know that there are 100 students surveyed, but some of them might not even count, right? They might not own a cell phone or a car, right? And it does say that here, 15 students didn't have either. So what we need to figure out first, if we want to figure out, okay, how many would own both? Or not both, but and or. They'd be, either one of those circles. What makes up both? So that's going to be 100 minus 15, so 85. That makes up that whole thing there, right? Okay, so now, if we think about this for a second, so it says 75 students owned a cell phone. So what does it mean by that? What part of the circle is it talking about? It's talking about this part of the circle, right? That whole thing. That's 75. So what would I get if I went 85 minus that blue shaded area I had there, 75, right? That was 75. So if I subtracted 75 from 85, what I'd be left with is this part, right? So then that's going to be my first part of the puzzle I can figure out. So all I need to do is go 85 minus 75, and that'll give me the purple area there. So let's go 85 minus 75. So we're going to have 10 that own just a car, right? That's on that side. Now we know part of our puzzle here too, right? We know that 45 students owned their own car. Remember, this is what we're talking about here now. 45 students means like that shaded area there, the whole thing. So if I go 45 minus the students that just own a car minus 10, what I should end up with, so I'll go 45 minus 10, that's going to give me 35, which is this middle area, right? So this is going to be 35. Now you could do this a few ways, right? Like there's actually a few options here. The other thing you could do now is notice that So 75 is this entire thing. So if I went 75 minus 35, I should be left with just this part of that circle. So we'll go 75 minus 35. So we're going to have 40. So this last part is going to be 40 on that side, and that's how that's going to be made up. One thing that you might want to do when you're looking back on this, though, is add this all up. Does 40 plus 35 plus 10, does that all add up to 85 like we were saying it did? In this case, it does, right? So you can just, that's a good check to go back to make sure that you're right. You should know when you're done these questions whether you got it right or not. You can check pretty easy, right? So okay, so I'm going to get you guys to pause the video now and try this one on your own. And then what I'm going to do is just pop the answers up at you, and you can check your answers with what I have here. So go ahead and pause the video now. Okay, here's what I got. So take a second, pause the video if you need to, just to kind of see, does yours match up with mine? If it doesn't, go back through and figure out what I did here. Why did they start with 100? Where'd that come from? All right. If you still don't know, come and see me or come and see your teacher. Okay. Okay, again for this one, I'm gonna let you guys go ahead and do this one on your own. So go to page 19 in your textbook, and yeah, solve this one. And then again, I'll pop up the answers. So go ahead and pause the video now. All right, and there you go. There's your numbers for that one. Yeah, and 34, remember, that's just the numbers that aren't part of my, like they're still part of my universal set, but they don't play volleyball or basketball. Right, okay. Now, something new. So the practice problem is written in set notation. You may find it useful to use your definition page to translate this symbolic notation into words. So yeah, so what we're gonna, like what we have here is it's saying things with these notations, right? But what we're gonna use is our your definitions that you've done, and we're gonna be able to decode this. Okay, so the way this thing works, and this is a good place to find this stuff, is on page 23 of your textbook as well. It goes through, like, especially these type of things. We haven't really seen these very often. So let's kind of go through these in order, though. So this n and then brackets, you can think about this as saying the number of elements in the universal set. That's kind of what it's saying. So the number of elements in the universal set is 50. So that means there's 50. So remember, universal set is everything in this box. Put a U up there if you wanted to. So there's 50 in that whole thing is what that's saying. Okay. Now the next part is saying number of elements in A. So we're obviously talking about circle A and circle B. Right? So number of elements in circle A is going to be 18. So we are talking about this right now, right? That is going to be 18, the whole thing. Okay? Now the number of elements in B is 26. So this whole thing would be 26. This part here, this is where it's new, and that's on page 26 there. The way this reads is number of elements in A intersection, that U upside down, that's the intersection area. So what is that? So when we talk about intersection, that's where they intersect. We're talking about that. That's going to be the intersection area. So that is 2 apparently. So if I want to start figuring this thing out, but yeah, let's figure out what's actually in here. So I just kind of erase these lines here for a minute. So I know what those are, so I'm just going to erase those for a sec. So I know in the middle here we've got 2. So if I go 18 minus 2, this is going to be 16 on this side, right? B, there's 26 in that whole thing. So if I go 26 minus 2, I've got 24 in that side. So now we've kind of figured it all out now, right? Last thing we got to do is just read this and know what it's even asking for. So this is saying A, and now the upside down U is easier to kind of like remember because it stands for union. A union B. So now what does union mean? Have you guys ever been to like a wedding where they said, like, you know, you've come, welcome to this union? You know, it's 2 things like together. So we're saying A union B means the entire area. So if you had two circles, the union would be everything, the whole thing, right? So that's what A union B means, but don't miss the fact that this is saying the complement of that. So the opposite of the union, almost everything but the union. So what we want is everything outside the union. So when it says A union B, but the complement of that, it's everything outside. So all we gotta do is figure out what what A union B is, and then just take our universal set and subtract that. So let's do that. So 16 plus 2 plus 24 is going to be 42. So we could technically say right now that N and then A union B without the little tick up top, that would be equal to 42. So this entire thing here would be 42, A union B. Okay, we want the complement of that. So all we have to do now to figure out the outside there is just take our universal set of 50, right? The whole thing was 50. So go 50 minus 42, which is 8. So A union B, or the complement of A union B, would be 8. Okay, moving on. Oh, never mind. That was the end of it. Okay, so make sure you guys check to see what's for homework. And that's going to be it for that video.